Hello. Today we will be talking about sensors and how they're used in engineering. With this, we will also be explaining the challenges and ethical issues surrounding sensors as well as possible solutions to consider.
Hello, my name is Andrew Davis, and I'll be defining, overviewing, and giving the significance of our topic, sensors. First off, what is a sensor? A sensor is any device that detects or measures a physical property in an environment. The sensor quantifies the data it's receiving from the environment and then passes this information over to the microcontroller for processing. Why would you use a sensor? Any system that interacts with its environment wants to detect or measure something from its environment needs some way of sensing it. Sensors are the answer. They measure and quantify changes in the environment, physical properties, and relays that information over to a microcontroller for processing. Now, in closed loop systems, the microcontroller itself is making a change to the environment. So it can heat something or change the air pressure or whatever. The sensors in that instance are used to detect the changes that a microcontroller made. So sensors also can act as like a sense of communication to close the loop for a microcontroller so it knows how it's affecting its environment or how it's affecting the physical properties of something. Some examples of sensors would include thermocouples for temperature sensing, accelerometers for measuring movements or accelerations, and even touch sensors for detecting interaction with the system itself. Next, I'll be discussing how sensors are relevant to engineering, design, and practice. We learned in the first slide that sensors basically measure and quantify changes in physical properties of an environment or substance. So we want to use these sensors in our applications, right? Deciding which sensor is best for our application can be hard. There's many things to consider. One of the first things you want to consider is what your application needs to know about its environment. What are you measuring? Temperature, force, position, pressure, chemical concentration? There's many different things sensors can detect. What's important is what does your application need to know about its environment, and that allows you to choose which sensor is best for your application. Each sensor is designed to detect a specific physical property change. The next thing we need to consider is should we use an analog or digital sensor? Analog sensors relay a continuous signal that represents a quantity learned from an environment. An analog sensor trades its efficiency for a more continuous and slightly more accurate signal, where digital signal sensors relay a logical value or a series of logical values. Logical value is basically an on or off type signal. So we are limited in our resolution by how fast a digital sensor can update. So a digital sensor will typically relay a continuous signal via pulse width modulation. As an example, a temperature sensor reading a high temperature would have a pulse width that is large comparative to a temperature sensor that is measuring a lower temperature. Its pulse width will be smaller. Another thing we need to consider is what environment will our sensors be in. If we're trying to detect something in a high temperature environment, we want to use a high temperature sensor. Something that can withstand the environmental issues. Electronics typically don't play well with extreme environments. Water, heat, and extreme vibrations can all cause faulty or unreliable data. To combat this, we use sensors designed specifically for what environment they will be in.
Hello, my name is Levi Troop, and I will be presenting the applications and social impacts of sensors. Firstly, I would like to explain briefly why we use sensors in the first place, since they are used all around us all the time. We use sensors for their ability to accurately and quickly measure various types of data in the system they are applied. This allows us to record and convert the data and use it for purposes like controlling operations and operating systems efficiently. As mentioned, applications of sensors cover a wide range of usage and incorporate many different technologies, which is why they have become so popular. Instead of trying to cover them all, I will explain two popular sensors in depth, which are accelerometers and temperature sensors. Accelerometers, in a summary, is a sensor that can measure the acceleration of motion of a system or structure. When the surface of acceleration is acted on the sensor, the material is compressed, which produces an electrical charge which can convert into measurable quantities. One of the most important usages of these sensors is in the automotive industry. They are used in airbag systems, and when the force of acceleration or movement passes the limit threshold, it can signal the controller system to deploy the airbag, potentially reducing damage to the operator and passengers of the vehicle. The second sensor I would like to talk about is the temperature sensor. These sensors are an electronic device that measures temperature and turns the readings into data to be recorded or monitored. The most popular application of this sensor is one anyone should be familiar with, and that is in thermometers. It is used to read a person's temperature, a system, or anything needing its temperature calculated. The most common application is in the healthcare field, where they are used to monitor patients' temperature to make sure they are in a healthy range. If it exceeds too high, then the medical staff know to be on alert and address it accordingly, allowing patients to be treated efficiently and effectively. Some other sensors that I won't go into depth, but wanted to share to help explain just how many they are, is the proximity, infrared, light, pressure, ultrasonic, touch, humidity, tilt, and flow sensors. Now, transitioning to the social impacts of sensors, it is no question now just how important and useful sensors have been in the different industries as well as our personal lives. Ever since the introduction of sensors, they have flourished into every aspect of our lives, with majority of people not giving it a second thought on their importance. Sensors have allowed us to increase accuracy, productivity, and efficiency whenever they are used. Sensors have helped us advance by automating the measuring and processing of data, whether large and small. One of the drawbacks that comes to mind is the fact that society has become a sensor society. What this means is that we have evolved into a society that is accustomed to having info readily available to us all the time. One of the most used devices we use every day and are almost dependent on is our cell phones. Cell phones have a wide array of sensors such as biometrics, accelerometers, and temperature sensors, plus more. It is not such a bad thing that we now expect this readiness of available data as the new norm, but it gives us a new perspective just how much they have positively impacted our world and how accustomed we are to their usage. Sensors will continue to get more sophisticated as new technologies emerge and provide us with more efficient applications of them.
Hello everyone, my name is Pinaki Upadhyay and I'm going to be talking about how and when engineering issues occur when dealing with sensors. As the use of sensors continues to become more widespread and varied, it is essential that engineers use the correct type of sensor for any specific situation. Some of the challenges that engineers face when creating sensors include accuracy, how close the sensor's measured value is to the ideal value, repeatability, the ability of the sensor to reproduce the same measurements after each reading, reproducibility, which means multiple sensors will give similar readings under the same operating conditions, range or span, which refers to the phenomena that a larger range results in poorer accuracy and reproducibility. So, engineers typically select the smallest range that satisfies the requirements. Reliability, how long a sensor can give proper readings. Often, engineers will create covers to protect sensors from harsh environments to ensure longevity. Maintenance, engineers being aware of how often sensors need to be replaced and keeping spare parts on hand. Safety, sensors must meet certain standards that have been developed to prevent explosions and other such catastrophes. And finally, cost. Many costs must be considered when developing a sensor for commercial or industrial use, such as the cost of transmission, installation, documentation, plant operations and maintenance, and more. Engineers must be able to create the most efficient sensor while keeping costs to a minimum. One major way that sensors are used to better society are wireless sensor networks. Wireless sensor networks are highly distributed, self-organized systems of multiple tiny sensors that are spread over a specific geographic area for purposes such as environmental monitoring, surveillance, target tracking, etc. The information collected by these nodes is then forwarded to a central location to be analyzed. There are 5 major types of WSNs. Terrestrial, which includes area and habitat monitoring, forest fire warning, and more. Underground, that mostly watches cave and mine conditions as well as landslide detection. Underwater, that deals with wastewater or water quality. Multimedia, which can be used for threat detection or incident monitoring. And lastly, mobile WSNs, which mainly help with healthcare. It is evident that sensor networks have great long-term economic potential, along with the ability to transform lives and solve many system-building challenges. However, because of many reasons, wireless sensor networks pose many engineering issues as well. A lot of WSNs deploy sensor nodes into harsh or uncontrollable environments. This can cause sensors to become faulty and unreliable. The framework for any widespread system must detect and notify events quickly. However, in a WSN, certain outside forces can cause there to be low latency or delayed communication. Oftentimes, WSNs require hundreds or thousands of nodes to be deployed in the sensing area, which calls for scalability. Transmission media, which means since the sensing nodes are connected through wireless channels, typical wireless issues can affect the system, such as fading or a high error rate. And the last issue is coverage problems, which reflects how well a sensor network is monitored and tracked by sensors. These issues all need to be managed in order to run an efficient wireless sensor network. Other challenges include, but are not limited to, the ability to send sensor data instantaneously and allow for real-time response. Very few systems are able to solve this problem currently. Power management is a prevailing challenge as battery capacity is not developing at a fast enough rate. And lastly, managing sensor nodes deployed across miles and miles of distance becomes very difficult for managers or operators. Therefore, an efficient remote control system is essential. And that concludes how and when engineering challenges occur concerning sensors.
Hello, my name is Tyler Davis and I will be presenting the ethical issues surrounding the use of sensors. When talking about ethical issues in any realm of life, we must start by defining what an ethical issue is. An ethical issue can be defined as any issue surrounding a topic that can conflict with common moral principles. So how are ethical issues significant in engineering? Well, when you consider the nature of engineering, all forms of engineering influence the people in society and their quality of life. When ethics come into question in engineering, it can not only negatively affect the outcome of an engineering project, but in turn significantly affect the lives of hundreds of thousands of people. With regards to sensors, there are many ethical issues surrounding this topic. Issues related not necessarily to the physical sensors, but how they are being used and how the data from these sensors is being used. And with sensors being involved in almost everything in our day-to-day lives, from our phones to our transportation to our homes with our AC systems, the data being taken from these sensors is primarily private information. But what happens when we don't know where this data is being sent to, or how this data is being used, or who has access to this data? That is where the ethical issues come into question with regards to sensors. An example of this can be found when looking into how psychiatrists are starting to implement sensor technology into their practices. Typically, psychiatrists make diagnoses for mental health based on patient history, objective data, lab tests, and clinical judgment. But with sensors that are already implemented into our daily lives, the future of psychiatrics is changing. With the new technology being integrated into psychiatrics, patients dealing with reported mental health issues will begin to be monitored through sensors in their personal devices. The use of sensors in this way is supposed to help identify high-risk individuals and help with early intervention for psychosis, which in theory makes sense, but when looking into a study done by John Rathborn, a health research specialist, the evidence was inconclusive that early intervention had any benefits. With this technology not having any measurable benefits, we should consider the ethical issues surrounding the use of sensors in this way. To start, If this technology was applied to children in society, this high-risk label being applied could negatively affect their self-perception and in turn how they behave in social circumstances. This is supported by many studies proving that labeling children at young ages, either good or bad, directly correlates with how they tend to act in a general sense. This, combined with concerns of high-risk labeling being public information, is quite concerning. If the high-risk label was public information, this could result in people dealing with mental health issues not having the same opportunities to do things like get a job or finding insurance. With the use of sensor technology affecting both younger and older individuals in these ways, the negative effects this could have on society would be detrimental, especially considering the mental health issues plaguing our country currently. Finally, we must take into consideration the privacy concerns surrounding these sensors. Will the data being collected by these sensors be private? Who will have access to this data, and how will the data be used? Unfortunately, the data collected by these sensors is not protected. As outlined in an article written by Scott Monteith, most patients may not have knowledge that data collected by apps that are not directly related with medical providers are not protected under the HIPAA. This means that because the data being collected by this technology is not protected, it can be sold to third parties, which leads to major concerns surrounding privacy. With all this being said, ethical issues surrounding the use of sensors is prevalent, and we must be careful to ensure that ethics are intact when using a technology that has the ability to be very powerful and useful in engineering as well as other realms of life.
Hello, I'm Dominic Jean, and I'll be informing everyone on the challenges and opportunities we'll come across with sensors. Yes, there are more problems to talk about. Like most things in life, there will be many hurdles towards improvement. Sensors tracking and exchanging data in real time while also improving with machine learning isn't an easy task. The sensors will first need to be already trained and have the proper data required. This involves a lot of research and deep knowledge in machine learning algorithms, which leads towards sensors being efficiently programmed in a way that could easily be used towards creating other sensors, allowing sensors to be mass-produced and altered if needed by other manufacturers for different uses. As stated before, there is a problem with resource underutilization. Multiple sensors giving off the same readings when it could have been done by just one. If we look towards wearable sensors, there is a possibility for chemical contamination. Not only does the skin serve as a barrier to analytes, but it can also contaminate analyte concentrations when collecting samples such as sweat, fluids, and blood. Bacteria consuming analytes can cause significant errors for blood or fluid samples when the volume is very small, and a needle is used to puncture the skin for fluid extraction. In terms of security, the three axes, confidentiality, integration, and authentication, must be achieved in any network for it to be called secure. This means maintaining the privacy of important data transferred, ensuring nothing is altered, and keeping the availability of WSN services at any time required. With challenges comes a chance for improvement. Advancing machine learning by itself can be the answer towards many issues. Increasing security with denial of service or DOS detection using statistical analysis and can also reduce all forms of congestion problems, leading towards reducing the energy consumption using active modes for the sensors. Intelligent sensors will know when they should lower their power usage when necessary. We can even improve the training process by reducing training time, relying on a small dataset, and improving accuracy. Medically, the chemical contamination may not even be a bad thing. This could be turned around and be used to measure the microbe-induced concentrations of analytes on the skin and even detect hormones. Finally, with software-defined networking, we can separate the control logic from the network devices. All the sensors will just have one simple job, while the hard part is being done by the SDN, lowering the amount of power used for wireless sensor networks. This alleviates dependency from vendors as well, making it easier for control over sensors. Though this does solve a lot of problems, it also has a risk of an attacker going for the main control. This is just another example of how advancement can have its challenges.
Here are 5 questions for the audience. Number 1, what is a sensor? Number 2, What are the impacts of sensors on society? Number 3, name 3 things an engineer must keep in mind when constructing a sensor. Number 4, what defines an ethical issue? Number 5, do the benefits of using software-defined networking outweigh the problem of having a central hub that comes with the risk of being hacked?
If you're interested in this topic, we've compiled a list of links that will provide you with more information. You can learn more about sensors and their types, get more info on software-defined networking, get a rundown on the challenges in sensor technology, and read more on the ethical issues surrounding them.
Here is a list of references that we used to collect information for this presentation.
Hello, this is Levi again, here to go over how our group utilized Microsoft Teams to collaborate and break down our presentation into parts to work on it more efficiently. Most of our team members have not had much exposure to the app, so the beginning was a little bit challenging getting familiar with everything the application has to offer. But after the first meeting, it was easy to keep track of our deadlines we set. First off, our team used the create a team function to form a private chat dedicated to our group. Using the generate code function to send invites to the members proved to be very easy and effective as we had to only copy and paste to join. Secondly, for our meetings, we used the start session function to hold a meeting, which automatically notifies each member and lets them join without a personalized invite. Having the ability to freely join and leave without any downtime was beneficial in case something came up. The most beneficial tool we discovered was the ability to share a Word document and PowerPoint slide inside of Teams itself, which updates in real time everyone's changes and work towards their portions we agreed on. Allowing the file to be opened and worked on in the same app was simplistic enough, and there is the ability to open the desktop app for the full range of features. Another organizational tool Microsoft Teams provides is the functionality to add multiple channels to help organize our workflow and not have everything cluttered into one chat. For example, one chat channel was our main meeting channel where we discussed meeting times, overview, and kept the shared Word and PowerPoint document. The other channel was for us to post our resources and other brainstorming ideas. This alone kept the workflow of our project to be very smooth throughout the entire assignment. Lastly, I wanted to provide our team's overall opinion on the Microsoft Teams application since we are all new to its usage in a professional setting. I could say most of us have exclusively used Discord, which is another video chat application, but it is more for casual atmosphere than it is professional. Our input is that Teams proved itself to be a beneficial and productive application throughout the entire project. With being able to have everything in one application and all its collaborative tools mentioned above, it allowed our team to be productive, communicative, and efficiently complete the project before the deadline.